First thing first, I will explain about what is the mixture problem. Mixture problem is one of the problems that involves the rate of quantity substance such as sugar, salt, and chemical substance. For this problem, it was controlled by inflow and outflow of the solution, which is happened simultaneously.
Problem statement. A tank with a maximum capacity of 500 liters contains 300 liters of brine, mixture of water and salt. A brine solution that had salt concentration of 3 kg per liter is pumped into the tank at the rate of 5 liters per minute. The solution in the tank is always stirred before it is pumped out at the same rate as the entering solution. Suppose the tank initially has 50 kg of salt dissolved in it. Question 8. Find the amount of salt in the tank after 2 hours. Question B. How much salt will be in the tank after a long time? Objective of the study. First, to develop a differential equation model that represents the change in the amount of the salt in a tank over time based on given inflow and outflow rate. Second, to determine the amount of salt in the tank after a specified time, specifically after 2 hours, using the derived differential equation.
To solve the problem about the mixture, the standard form that we need to construct is dA over dt plus R2 over Vt times A equal to C1 R1. Each of the variables has their own meaning, such as dA over dt is a rate of change of the amount of the substance in the tank, and R1 is inflow rate of the solution. C1 is indicated as a concentration of the inflow solution, while R2 is outflow rate of solution. There are one variable that needs a small calculation, which is Vt, which is volume of solution in the tank at any time. To find Vt, we need to know the initial volume of the solution and add this volume of the solution that entered the tank and minus it with volume of solution that leaves the tank.
We go to the solution. For question A, let A in bracket T represent the amount of salt in kg in the tank at time t minute. Initially, the tank contains 300 liters of brine with 50 kg of salt dissolved in it. The inflow brine has a constant salt concentration of C1 equal to 3 kg per liter and enter the tank at a rate of R1 equal to 5 liters per minute. Therefore, the rate of which salt enter the tank is given by rate in equal to C1 multiplied by R1 equal to 3 multiplied by 5 equal to 50 kg per minute. The outflow rate is also R2 equal to 5 liters per minute since the inflow of outflow rate are equal. The volume of solution in the tank remains constant at 300 liters through the process. Because the solution is well stirred, the concentration of salt in the tank at any time t is uniform and is given by C2 equal to A in bracket T over V in bracket T equal to A in bracket T over 300. Hence, the rate at which salt leaves the tank is rate out equal to C2 multiplied by R2 equal to A in bracket T over 300 multiplied by 5 equal to A in bracket T over 60 kg per minute. The change in the amount of salt in the tank over time is difference between the rate of salt entering and leaving the tank. This leads to the differential equation, which is dA over dt equal to 15 minus A in bracket T over 60 with the initial condition A in bracket 0 equal to 50. This differential equation model the mixing process and allow us to determine the amount of salt in the tank at any time t, as well as its long-term behavior. To find the amount of salt after 2 hours, which is 120 minutes, we substitute t equal to 120 minutes. So, A in bracket 120 equal to 900 minus 815 exponent the power of negative 120 over 60. So, we got 900 minus 815 exponent the power of negative 2. So, the answer is 784.97 kg. Therefore, after 2 hours, the amount of salt in the tank is approximately 784.97 kg. Next, we go to the question B. To determine the amount of salt in the tank after a long time, we consider the behavior of the solution as t to infinity. As time increase, the exponential term, the power of negative 1 over 60 t decrease and approach 0 because the exponent is negative. Therefore, limit t to infinity, a in bracket t equal to limit t to infinity in bracket 100 minus 850 multiplied by exponent the power of negative 1 over 60 t. Since exponent the power of negative 1 over 60 t equal to 0, then a in bracket t equal to 900 minus 850 in bracket 0 equal to 900. This means that after a long period of time, the amount of salt in the tank approached 900 kg. At this stage, the system reached a steady state condition where the rate of salt entering the tank is equal to the rate of salt leaving the tank, and the amount of salt remains constant. Lastly, we go to the discussion. This problem represents a mixing process where brine enter and leave the tank at the same rate, so the volume remains constant. The amount of salt in the tank changes due to salt entry from the inflow and leaving through the outflow, which can be modeled using a first-order differential equation. The result after 2 hours show how the salt amount increased from the initial value after a long time. The system reached a steady state where the rate of salt entry equals the rate of salt leaving, and the amount of salt become constant. This illustrates how differential equation can be used to analyze real-life mixing process.